Okay, now we're going to start a new chapter. Let's start like this with this equation. When solving an equation, all you're trying to do is you're trying to find a value for this variable such that a number for that variable such that this entire math sentence is true. Now, when you have an equation with one variable, then all you need to solve this is one equation. However, if you have an equation with two variables, you need two equations. Notice here now I have two variables. I won't be able to solve it on its own. I need to solve it with another equation. Now there's three ways to go about this, and we're going to deal with all three ways. First way is we can solve by graphing. Now these are both linear equations. In other words, they're the equations, if you graph them, they're going to be lines. What a solution to this linear equation is going to be where those lines intersect. When you solve this equation right here, what you end up with when you solve it is a solution for just x, because that's the only variable that you have, right? So if you end up with this right here is what we consider a solution. Now notice what we come up with is a value of x that makes this entire sentence true, such that if I put that value in to my equation, I'm going to get a true statement. -2 plus 5 equals 3. Yep, looks like a true statement to me. Did I? Okay, so here now I need a value for x and I need a value for y that makes not only this one true, but it makes that one true as well. So if you come up with a value for x and a value for y, then what you're looking for is an ordered pair xy. So if we graphed both of those lines, where they intersect, being that they intersect right here, where they intersect is a solution to this system of equations, meaning that it's a solution on each one of these lines right here. So it's on both lines at the same time. That's the only place. That's how we do things graphically. So really all you're doing is graphing the lines and then finding out where they intersect. I'll do a quick example, solve this system graphically. If I'm solving this system graphically, let's actually just do both of them real quick. Let me put them in slope-intercept form first. Okay, took care of that. So now let's graph y equals -4x plus 8. Y-intercept being 8. And the slope being -4, so I'm going to go down 4 over 1. And let's draw that line. So I graphed y equals -4x plus 8, and you have that line. I want to make this line nice and long, so just to see where this is going to intersect. So let's graph the line y equals 3/2 x minus 6 now. Actually, I made a mistake on the slope. The slope is not 3/2. The slope is actually 2/3. Hold up one sec. See, I made the mistake a lot of other people make, but what I needed to do was just realize why things weren't working out the way that it does, or it's supposed to, or if it does make sense. So the slope is actually 2/3 as opposed to 3/2. So let me try and graph that now. And as you can see, they intersect at the point 3, -4. So I should put it over here that 3, -4 is a solution to the system. In other words, put that order pair with that 3 in for x, -4 in for y, and you're going to get a true statement. Wait a minute, let's verify that. It works for 4x plus y equals 8, and it also works for 2x minus 3y equals 18. So yeah, we have that as being our solution to this graph. Now, there are basically 3 cases that you can come up with when you're talking about the number of solutions of linear systems. The one that we just did, we ended up with 1 solution. In other words, 2 lines that intersect, they can only intersect once because they're lines. So we have 1 solution. This is actually called a consistent system. Then you have no solutions, which is considered an inconsistent system. And then you have infinitely many solutions, not all real numbers, but infinitely many solutions, which is actually considered a dependent system. Just a little bit of vocabulary, a couple of words to deal with. We'll get to that further, but I'll do one of these just so you guys can understand what I'm talking about. Say if I'm trying to classify this system whether or not it's consistent, consistent, independent, consistent, dependent, or inconsistent. So if I graph this right here, well, first I simplified it and put the equations in slope-intercept form, and from there I can notice immediately it's the same equation of a line. So if I graph that equation, it's just one line on top of the other. So this system, we will call this system dependent. I didn't spell dependent right. Call this dependent. This one over here, first off, let me simplify it into slope-intercept form like this, and then let me graph them. Okay, I graphed the red line. Notice I'm color coding everything, right? Also notice that these have the same slope. Slope being -2, so our slope being -2. So if I graph the blue line now, you'll get parallel lines. So since you have parallel lines, that means that there's no, well, I should say here, it means that it's inconsistent. And let's, oh, it didn't write it right. Now, when I should go back over here, and when your system is dependent, in other words, it's the same line, then there are infinitely many solutions. And when your system is inconsistent, you have no solution, because the 2 lines don't intersect. So we have that. That's graphically. Now let's move on to algebraically. Solving your system of equations algebraically can either be done one of 2 ways. Either be solved by substitution or solved by elimination. Solved by substitution, it's easy to just recognize when that might be a better thing to do than elimination. Usually it's going to be elimination, but sometimes substitution actually is less of a headache. For example, say this problem here. If I wanted to solve that system, obviously I graph it to see where they intersect. Or I can solve one of the equations for one of the variables. So say if I go here and I solve x plus y equals 15 for one of the variables, then that would mean y has to equal negative x plus 15. So if it does, we did step 1. Step 1's done. Step 2, substitute this expression into the other equation and solve for the other variable. So I can take this and substitute it here. So if I substitute it here, now I'm talking about 4x plus 3, hold on, 4x plus 3 times negative x plus 15 equals 38. Notice that y equals negative x plus 15. So if y equals negative x plus 15, then I can just substitute, instead of writing a y here, I can just write negative x plus 15. And then I can solve. 4x minus 3x plus 45 equals 38. X plus 45 equals 38. X equals negative 7. Now mind you, we're not done. We only have one part of the solution. We only have the x value. So what we're going to do instead, step 2 is done. If we go to step 3, substitute the value from step 2 and solve. So substitute the value from step 2 and solve. If you have x equals negative 7, I will plug that back into the simplest equation that I have. So if x equals negative 7, that means that negative 7, write it a little better than that, negative 7 plus y equals 15. So that means that y has to equal 22. So your solution, I don't know what happened, there we go. So your solution is negative 7, 22. It's the ordered pair. In other words, that's where they intersect. And we just found that out algebraically. So I want you guys to understand that this part right here is your solution. Now, if you check it, it should that should make both of those equations true. Absolutely. 22 plus 7, oh I'm sorry, negative 7 plus 22 is 15. Absolutely. 4 times negative 7 is 28, plus 3 times 22 is 66. That should give you, that should be a true statement as well when you subtract those. When we solve by elimination, solving by elimination is pretty much just add the equations together. I like to keep it as adding the equations together, not adding or subtracting, because I don't want to mix the signs up. But just add the equations together. So just like anything else, there's a plus sign, and I'll just add those. If I add those equations together, 5x plus 3x is 8x. Let me zoom in. 5x plus 3x is 8x. The negative y and the positive y cross out. The reason why we add them together is so we could cross out one of the variables. And we're left with a simple equation after that. 8x equals 16. X equals 2. Again, we're not finished. We only have the x value, so we got to plug that back in to one of these, right? So let's plug that back in. How about we plug it in here? 5 times 2 minus y equals 12. Now that's pretty much just 10 minus y equals 12. Negative y equals 2. Y equals negative 2. So the solution to this is, I'll write it out, 2, negative 2. It's our solution. Notice in this problem over here that it's not the same thing, because we can't just add these together and one of the variables go away. No, we actually have to multiply one of these by something to get one of these variables to cross out. So what I'm going to do is I'm going to take one of these equations. As long as I multiply everything by it, it's going to remain the same. Let's take this top equation right here. and I want to multiply it by a -3. Now watch what that does. When I multiply that by -3, let's rewrite the actual equations. Okay, I rewrote the bottom equation. The top equation, if I multiply the entire thing by -3, now I have -3x plus 6y equals -12. Now, I'm actually glad that this happened. So, if I add those two equations together, adding both those equations, look what happened. When I add -3x and 3x, gone. Positive 6y and -6y, gone. So what we're left with on the left side is 0. What do we have on the right side? On the right side, -12 plus 8, -4. Now obviously this is a false statement, right? So because 0 doesn't equal -4. So since there's a false statement, there is no solution. And you know, when you have no solution, that means that the lines are parallel, meaning that they have the same slope. And if in fact you put both of these lines right here in slope-intercept form, you'll see that they better have the same slope, because you ended up with no solution. I don't want to make this longer than it actually is, so we'll do more of this in class. It kind of just gives you an idea of the systems of equations. So that's all we'll do, and I'll see you guys.